Sometimes it's easier to balance redox reactions using the oxidation number method. This method uses the fact that the total increase in the oxidation numbers of the oxidized elements equals the total decrease in the oxidation numbers of the reduced elements. Follow the specific steps below. Write the unbalanced net ionic equation if it's not given to you in the question. Then assign oxidation numbers to all of the elements. Find the numerical values of the increase and decrease in the oxidation numbers. Determine the smallest whole number ratio for the oxidized and reduced elements so that the oxidation number increase and decrease are equal. Use this ratio to balance the number of atoms of the oxidized and reduced elements. Balance the other elements by inspection if possible. And for reactions in acidic or basic conditions, include water, hydrogen ions, or hydroxide ions as needed. Let's have a look at example 3. I need to assign oxidation numbers to each of my elements. Hydrogen will be +1, and because I have 3 of them, the nitrogen needs to be a -3. Because oxygen is in its elemental form, it'll have an oxidation number of 0. In NO, the oxygen is a -2, leaving nitrogen to be a +2 to balance it. And for water, hydrogen is +1, oxygen is -2. Because the nitrogen goes from a -3 to a +2, it's oxidized with an increase of 5. The oxygen goes from a 0 to a -2. Therefore, it's reduced. Because the increase and the decrease in oxidation numbers need to be the same, I need to try and make them both equal 10. In order to make my increase equal 10, I need 2 nitrogens to be oxidized. And in order for my decrease to equal 10, it means I'll need 5 oxygens. This 2 here makes it a little bit tricky. So if we put a 5 here, that gives me 10 oxygens, and I double the amount of nitrogens, then I'll have an increase and a decrease of 20. This will get me the balanced chemical equation without any fractions. Now I balance the elements on the other side by inspection if I can. I have 4 nitrogens on the left. That means I need 4 nitrogens on the right. Because acidic or basic conditions aren't mentioned, I should be able to balance the H's and the O's. For hydrogens, I have 4 times 3, that's 12. That means I need to put a 6 in front of my waters. And for oxygens, this gives me 10 on the left, 4 plus 6, that gives me 10 on the right. I'm now balanced. Balancing under neutral conditions is the easiest. It gets more complicated under acidic and basic conditions. Let's have a look at example 2a. First, I need to assign oxidation numbers. Because the zinc goes from a 0 to a +2, it gets oxidized. And because the sulfur goes from a +6 to a 0, it gets reduced. I need to have my increase and decrease equal to the same number. If I times my zincs by 3, that gives me an increase of 6. So I need to react my zinc and sulfate in a 3:1 ratio. Now I can balance as many elements as I can through inspection. I have 3 zincs and 3 zincs. I've got 1 sulfur and 1 sulfur. Because I'm under acidic conditions, I then balance my oxygens by adding waters. I'll need 4 waters on the right side. And that also means that I'll need 8 H pluses on the left. My final balanced equation will be 3 zincs plus a sulfate plus 8 H pluses produces 3 zinc 2 pluses, a sulfur, and 4 waters. Let's make sure everything's balanced. 3 zincs on each side, 1 sulfur, 4 O's, 8 H's, and I have a +6 charge net on the left and a 3 times 2 +6 charge on the right. Pause the video here and try out example B. To make it easier, let's add a plus water on this side. Here's the answer to example 2. Start by writing oxidation numbers for each of the elements. Because my iodine went from a -1 to a 0, it got oxidized with an increase of 1. My oxygen went from 0 to -2, so it was reduced. I need my increase and decrease to equal the same number, so I need to have twice the amount of iodines. Because there's a 2 already here in my equation, I'll make the increase and decrease the same by adding a 4 in front of my iodine. I balance the i's on the right side by putting a 2 in front. I'm under basic conditions, so to balance the oxygens, I'll need to add another water. I'll indicate that with a 2. And I'll need to add 4 H pluses to the left side to balance my hydrogens. Now to change it basic, I add 4 hydroxides to each side. This simplifies down into 4 waters. However, 2 waters are spectating. Let's check to make sure things are balanced. I have 4 I's on each side. I will have 2 plus 2 more 4 O's, and I have 4 H's and 4 H's. net charge, I have 4 minus on the left and 4 minus on the right.